Okay, so yeah, relational algebra, it's just an algebra to talk about sets, to talk about addition, subtraction, multiplication, in the same way that you have algebra for how to manipulate numbers. If numbers are the things that you care about manipulating, you can also care about manipulating sets. So you can add them, you can subtract them, you can multiply them, you can combine them together in different kinds of ways. And the idea is that you have a bunch of different sets that are all kind of little constellations that have little bits and pieces of information that you care about. And that can be considered all of your sort of data. And then when you query your data from all of this, you want only part of it as a result. And that so you can take different of these sets, you can manipulate them in different ways, create intermediate sets, and at the end, you end up with one set that's called the result of the query, which is just whatever set you end up with after going through all of this manipulation stuff. Now, the way that, like SQL, it's a relational database, which means that it works with relations. So relational algebra are the operations that you have to manipulate relations. And therefore, SQL, which is a querying language, it's just a different vocabulary, but all of the operations are the same. The way that you would write a SQL query is almost identical to the way that you would structure a query in relational algebra. Yeah, but relational algebra is a cleaner, more pure sort of look at relations. But once you're comfortable with it, then being able to make competent SQL queries is going to be much easier. Okay. So we've talked about the different operations, and there's really only 7 of them. There's the union, the intersection, the set difference. Here, the types of the relations need to be the same. That means that their column names need to be the same name and type. So they have to have the same schema. Then we have, we can do multiplication. That's called the cross product. You can do projection, which is basically deleting an entire dimension of the relation or deleting an entire column. And so every single vector, every single row that exists in that table will have that element or that value deleted from them when you project. So, for example, taking this relation with 3 attributes, name, age, and lot, I can project it and just delete that lot column. Okay, that's what a projection does. There's select. This deletes rows or eliminates individual points from the set. And that's it. The natural join is like a more higher level abstract useful thing to use once you know how it works, but I'm not talking about it in this class. Or we're not using it in this class. Towards the end, I'll say more about it. Towards the end of this semester. Okay. And now, for today and next week, it's going to go like this. We're in relational algebra territory, and we're going to be going through some examples of queries. Each example is trying to convey a certain situation that you might find yourself in, or that one might find oneself in when trying to make a query. So, of course, there's an infinite number of possible queries that you can make, but they'll have certain patterns. And so by going through about 8 or 9 different examples that will get sort of progressively more complicated, I think that we should cover, how to put together a query using this relational algebra. After that, it will be about 1 week of showing you basically how to translate from a relational algebra into the SQL language. That's very quick. If you understand relational algebra very well, then the jump to SQL is very small. And then we'll get into the technical stuff. So start talking about projects and getting you guys on Azure and putting together, working with an actual database and querying and this kind of stuff. Okay. Now, when we're going through these examples, I'm going to pause afterwards and give you some time, like maybe 4 or 5 minutes, to try to come up with the query yourself. And I think it's very important that you take the time to do that. It doesn't matter if you find the query or not. The process of trying to get it, or trying something, seeing if that doesn't quite work, or whatever, I think that's a really important part to understanding or getting comfortable with relational algebra. So please don't, I don't know, check the news or something during these times. Okay. Just a quick review of the 2 queries that we've talked about. This is the first one. Find all restaurants frequented by at least one person under the age of 18. And the way that this is evaluated is from the inside out, just like normal algebra, right? If you do 5, 4 plus 3, or I don't know, let's say f of 2, where f of x is x squared, then this, first you'd evaluate this f of 2, because that's x squared, that evaluates to 4. Okay, so now you're done with that. Now you do the inside parentheses 4 plus 4, that equals 8, and you do that, and now you multiply it by 5. Okay, you don't do 5 times 4 first plus whatever stuff. I'm sure you're comfortable with the way that algebra works. So relational algebra works the same way. Things are evaluated from the inside out. So here, we have a cross multiplication between 2 relations. This is going to create one large relation that has all of the columns of each of the relations. In this case, there would be one relation that would have a name, an age, and a gender column. That's coming from the person. And then this relation would also have a name and a restaurant column. And that comes from the frequence relation. So those are just the columns. But because it can make things easier if each column has a unique name, then we do this renaming of the frequence. So instead of name, we're going to call that name 2. So we know that names from here is coming from the frequence relation, and names here are coming from the person relation. So that's just the columns. And then for the values, it's all possible pairings. So John, who's 16 and male, will get paired with Mary, who goes to McDonald's. And then John will get paired with Susan, and John will get paired with John. Sorry, Susan, Henry's, right, and on and on. Okay, so that's the result of this cross multiplication and renaming operation. After that, we have the select operation, and the select applies a predicate, and we'll be talking more about predicates. A predicate is just a statement that is either true or false. So there's one statement: the age is less than 18, and the value for name 1 equals the value for name 2. Okay, and that is either true or false for each row or each element of the set. So you take this true-false statement, and now you start applying it row by row. And you keep the rows when the statement evaluates to true, and you delete the rows when the statement evaluates to false. So here, for example, this first row would be eliminated because the age is not less than 18. And so that's what the select does. It will go row by row, deleting things that don't match the predicate. And then finally, there's a project here. And what this project will do is to keep only the restaurant column, and it will only return this one column of this relation, because we only care about the restaurants. We don't care about the name and the age and the gender and that. Like, the query is about what are the restaurants, so we only return the restaurant names. Okay, so that's what the project does. Okay. Yeah, and in this way, you're taking two relations, person and frequency, and now you're manipulating them, right? Cross multiplication and select and project, and then you end up with one relation, that's this one in the green, and then you stop, and whatever that relation is the result of the query. So this whole thing here is a query, and the part in green here is the result. All right, any questions about that? No. Okay. This one just adds a little bit of a tweak. It's now we want the names of females, so not restaurants, but we want names now of females who eat either yogurt or salad or both. And the form of the query is almost identical. The only change here is this part, that in a predicate, you can have something like this. So the gender is female and the food is yogurt or the food is salad. Like that's, you can do that with a select statement. And still, this whole select statement, that's one predicate. So it's that whole thing evaluates to true or false given any row, and you delete rows in the way we just talked about. Okay. Okay. That was about set stuff. If you have any questions about this, please type or unmute yourself, because these things are only going to be getting harder. So if you're lost now, best address it early. Okay. Let me turn off this video. Okay. Find the names of all females who eat both yogurt and salad. Okay, so this is very similar to example 2, where this is finding the names of the females who eat either yogurt or salad. Now, this is wanting females who eat both yogurt and salad. Okay, so it's a little change from before. Okay, I'll give you 4 or 5 minutes to work on this, and please do actually try to write down a query. It will make your life much easier if you take the time. Okay, so I'll check in like 4 or 5 minutes. Okay. So, anybody think they have something they'd like to try? Wonderful. Okay.
Can you hear me?
Yes, I can.
All right. So, what I was thinking was like for what was given was like gender is equal to female. Um, then you do the and sign, and then you do like food equals salad, and like another and sign, and food equals yogurt.
Yeah, you can just say and. So wait, I'm sorry. Gender equals female and what?
Then food equals salad,
Okay.
and uh, food equals yogurt.
Hmm. Okay.
And then you like in parentheses you would write person times the rename sign,
Mm-hmm.
and you write name equals name two,
Okay.
and then it would be eats,
Okay.
and that's all I had.
Okay. Oh, so this would be a select, I guess.
Yeah.
Yeah. So yeah, here you can just say select or sigma,
Okay.
sigma or select. And here, yeah, you can just say rename. That's fine. That's also row. Yeah. So the rename, like whatever, the first letter should match. That's actually why they choose these letters. I don't know why they choose the Greek, but yeah. Right. So there's a couple of things. Actually, yeah. Where are those? First of all, um, uh, because we want the names of all the females, let's project this with just name, because that's the only thing that we care about from all of this. Um, by the way, this yeah pi for project. Right? Okay. Now here you're renaming, but you don't use name two anywhere, or you're not using this anywhere. Okay. I see a question about the arrows. Yeah, this arrow just means to change the name from one thing to another. So change the column name. So here in the eats, here, this. Change this column name from name to instead be name two. That's all that it is. It doesn't really matter. I mean, like if you put name equals name two, whatever, like, yeah. Stuff like that is, I consider small stuff. But okay. Yeah. So in any case, one thing that you want to not forget is that the names should match. Right. The reason why we rename here is so that we can select just when the two names match. So, for example, Peter. Here is the name Peter. And Peter doesn't exist in the eats column here. So any notion, anything that has Peter will be eliminated because of this, because the names don't match. We want the names to match because, for example, well, Amy, she eats both. So Amy, her name appears here when she eats salad, and her name also appears here. So when these two are paired together, like of these pairs, these are the two pairs that will be kept. Amy 25 female, Amy salad, and Amy 25 female, Amy yogurt. Those would be the ones that would pass through most of these. So that's why we care about the names matching, because we want to know that this person here is the same person as here. And we recognize them being the same person because their names match. Okay, here, this is a connection that could exist, and you might have a reason to care about when the names aren't equal. But in this case, we care about when the names are equal. Okay. There is another problem with this. That's a very big problem. I want to know if anybody can spot it. With this query, there's a very big problem with it. In fact, I'll narrow it down here. Can anybody see a problem with this? Should there be parentheses? No, that doesn't matter.
Would it have to be name equals name too?
Oh, sure. Sorry. Yeah, that should be name equals name too. Thank you. But that's not the problem.
Oh, would it be the food equals salad and food equals yogurt has to be in parentheses?
Ah, well, you almost had it. Yeah, there's a problem here.
Oh, is it a food should be either salad or yogurt?
No, because then that would be that would make it equal to this query.
Oh,
Right?
yeah, my bad.
Yeah, where there's an or. In all other cases, this is the same query. The only thing that's changed from this query and the last is that now this is food equals salad and food equals yogurt. Okay, let's for this time, let's start to go through it a little bit more in depth, what this process is doing. I'll only do this one time. Okay, so actually, let me pick out on some people just to help me go through this, just for practice. People are being. It is not possible to show both foods. Yes, that's really the problem. But yeah, a food cannot be two things at the same time. But anyway, just for practice and because people are being very quiet, it's making me nervous that, yeah, people are so quiet. So how about Carlene? You have a mic? Maybe Carlene doesn't have a mic. Okay. How about Justin Xie or Justin Shea? I don't know.
Hello?
Yeah, is it Xie or Shea?
Shay.
Shea. Okay. Great. Let's evaluate this from the inside out. Okay, so like how this would actually go. Here, where's this? So yeah, well, whatever. We're gonna start here with this. So how does this relation look like, or what does it look like? How does it work?
So for every, I guess, per person that information is multiplied into eats, so every single column will be multiplied to every single column to eats, one at a time.
Yeah. Okay. So I'm trying to make this legible. So yeah, this person whatever. Okay. I'm sorry. Say that again. Can you?
So like you did in the last problem, it's basically every single row in person will be multiplied to every single row in eats to get the full amount of information for this cross multiplication matrix.
Okay. So what are the rows of this? Or I'm sorry. What are the columns of this relation?
For person, it's name, age, and gender. And then for eats, it's name and food.
Okay. Okay, and I've renamed this the name two. That's the our name to name two thing. Okay, and so what are the rows?
So for person, the rows are John.
Mhm.
Oh wait, did I want to go to like just the first, like the name, or every single one?
Yeah, like this entire row here.
Okay,
What is the first row?
So it's John 16 male, and then John yogurt.
Yeah. Okay. Good. All right. You want to keep going? Well, we're going to go through the whole thing. So I'll try to type as you speak.
Okay, John 16 male. Amy salad.
Mhm.
John 16 male, Amy yogurt. John
Okay.
16 male, Jane salad.
Okay.
And then Peter 19 male, John
Right.
yogurt. Yeah.
Yeah. So yeah, I'm just saying you're doing this, right? Okay. So that was that. Those are these four rows, and now you're going to do these four rows, right?
Yeah.
Okay. Yeah. Good. Yeah. Uh, oh, it's really annoying. Um, I wonder if I can copy all of these. That'd be great. No. Stupid. By the way, while I'm doing this, if there's people who have already sort of spotted what the problem is here, if you can try to come up with a query that you think might work, in the meantime, that would be great. Um, oh, finally. Okay, there we go. So that is the cross product. Hold on. I'm not sure if this is just to keep it simple, but wouldn't there be an error if there was 2 Johns, both the age of 16, and they ate different foods? In this example schema, are we just assuming there could only be one of each unique to the name? I guess you're talking about the like here in the person. Yeah. Yes. So that would be a problem, but that's something that is not allowed in relations. So we haven't started to talk too much about primary keys and stuff. But here, you could have the name as the primary key, in which case you could have a different John who's a different age, and that's okay. If you had the name and the age as a key, then you could have let's see. Right, then you could not have 2 Johns of the same age. This wouldn't even be allowed because both the name and the age are chosen as the primary key. So when you tried to add this, then these two would conflict now, and so this would not be allowed to be even added to the relation. You'd get an error. For each of these, and a default is to just use the entire thing as a primary key. And that means that no 2 rows can be completely identical. If you tried to add such a row, then the insertion of this wouldn't work. You'd get an error for it. Yeah. So yeah, here I'm assuming that at least the name and the age are the primary key. But if you want to make it easy, just take the whole thing as a primary key, and it works. Okay. Wonderful. Okay. Now let's look at the next part of this query. Okay. So this is the green part. Okay. That's done. That's in full. This is the entire thing. Okay. Now let's try to do the select, and I'm going to pick on a different person. How about Mark?
Hi, how's it going, Professor?
It's going all right. Okay, so let's try to do this, the select now, this part of the operation. Still working inside out. Okay. So how does that work?
So I'm thinking, okay, so you're selecting, let me see.
So this select is being applied to this whole relation here, this whole thing.
Gotcha.
Mhm.
So, where gender equals female, so I guess if you just flow through, like, it would choose, okay, first, like, okay, is the gender female? And
Okay.
I guess, like, if you can answer my question, I'm not really sure.
Mhm.
Like, when we do, like, food equals salad, food equals yogurt,
Mhm.
we can do it, like, 2 separate lines instead of, like, maybe indenting it so, like, it has to be, or, like, that's the way we present it. Like, if it has to be both conditions, like, food has to equal salad, food has to equal yogurt, then we could do it in, like, 2 lines, like how we did in the highlighted region.
You can do it in 2 lines. Yeah, you can't really do it in 2 lines. It doesn't
Okay.
work like that.
Okay.
So let's. So this is going to go row by row,
Yeah.
and check whether to keep them or not.
Okay.
So let's start with the first row. Is this kept?
No, because gender is male in this vector, so we're gonna remove it.
Okay, so we get rid of that. And by extension, I'll just get rid of all the other males we see.
And then it'll go
Okay,
straight
for
to
the same reasoning. Okay, great. Now we look at Amy.
Yeah.
Do we keep it?
So in this case, if we just roll through, at first, okay, it says gender equals female, so it looks good.
Mhm.
And then the name though, like the last condition doesn't match.
Yeah.
So we
Yeah,
cancel it.
here. Okay, great. Okay, how about the next one?
So the name matches,
Mhm.
and I can't really see the full
Mhm.
the full. Okay, so we keep it because food equals salad and food equals yogurt in the next row, so we keep those two.
Nope, doesn't work like that. It goes
No,
row by row. No
row by row.
combinations of rows.
Gotcha. All right,
Mhm.
so we keep that row. Great.
But doesn't that violate this? Does the food equal yogurt? So yes, the names match. Yes, it's a female.
Oh, okay. I get what you're
Yes,
saying.
they have a salad. But so these three, they're female, the names match, and that does equal salad. But
But okay,
does the food equal yogurt?
that's right. Okay, I
Yeah.
get what you're saying. So no. In this case, we would cancel it, even though we would consider that. Okay.
Yeah. Right. Now, okay. So all of these are going to get canceled.
Okay.
Do you see why, or do you want to go through it? No. Okay. Let's go through it a bit more. How about this one? Do we keep this one?
By the same logic, no.
Yeah, because now we have yogurt, but that is not equal to salad. So then
Yeah.
that goes away. And now here the names don't match, the names don't match, the names don't match, the names don't match. And here, fine. But here the food is not equal to yogurt. So that gets eliminated. Okay. Now, if we look at these relations, Amy should be returned, right? She's a female and she does eat both yogurt and salad.
Yeah.
Okay. So there's something wrong here because when we run this query, we get back an empty result instead of getting back Amy. And this is the big problem here. Because the food cannot in a single column in a single row be both salad and yogurt. Can't do that. Yeah. So the way that this is with these eats, you don't have, there is no salad / yogurt. You can't do that. Would get really messy if you try to do that. Okay. Thanks very much. Yeah. So hopefully that points out in great detail the issue here. Does anybody think that they have an idea for how to fix the query? Create a food to column. Okay, Hassan, how would that work? Not sure, just a thought. Well, unmute yourself because it's a good thought. This can work.
Hey, Professor.
Hey. Okay, so you say create another food column. Which of these two relations has a food column? Person or eats?
Eats.
Great. So, we need to get, your idea is to have two different rows for food.
Mhm.
Two different columns for food. That way, a single row could have two food things, right?
Mhm.
How would we add another food row to this? So here, I'm sorry. You want another at least another food column here.
Mm-hmm.
I don't know, maybe we'll call it food 2. And that'll be text. How do we get that column there?
Wouldn't you just maybe it's like another criteria you have to do under eats?
Another criteria under eats.
Like, you know, where it says like name.
Yeah. Mm-hmm. But for this eats is responsible for these 2 columns. So if, for example, here you put food to food 2, you could do that. You could rename more than one, but then that will be renaming that column to food 2. It won't be creating another column, a new column.
I see.
So that doesn't quite work. There's an operation that we've already seen of how to expand the number of columns.
Let me check 1 sec.
Okay, Mark says another cross multiply. Does that sound reasonable to you?
Yeah, it sounds reasonable.
Okay, so how would that work? If we do another cross multiply.
So it'd be it'd be a column with the eats and a column with the person. So wouldn't it just be eats times eats?
Yeah, very good. Yeah, excellent. So and now you can rename the food to food 2, and I don't know, name to name 3, if you like. Then that will add more columns. Now we'll have more columns. So this will have food. Now we'll have name 3 and food 2. And very good. Yeah, so now first you do the same thing with multiplication in algebra. If you do 2 times 3 times 6, you can first do that, 2 times 3, which is 6, and then multiply by the 6 and get 36. Or, if you like, you can do that part first, 3 times 6. I'm sorry, that's not right. Yeah, 18 times 2, and that also equals 36. So whatever. You can go piece by piece. So this is that. We already have this relation. And now for every one of these relations, you can pair it again with the food, or with the eats. So then you'd get John 16 male, John yogurt, John yogurt. Then John 16 male, John yogurt, Amy salad. John 16 male, John yogurt, Amy yogurt. And then you would, have many, many more rows to this table because of all of the pairings that you'd do. You'd get this pair, then, you'd get this pair, and that's a lot of pairs, right? Great. So how about Alex?
Yes, Professor?
Okay, so this query is almost finished. Do you know where it needs to be touched up? I'll give you a hint, it's there.
Oh, yeah, so we need to change it so that it's referring to food 2 or like food underscore 1, like food 1 is salad and food 2 is yogurt, or food 1 is yogurt and food 2 is salad, something like that.
Yeah, sure. Yeah, just this. Yeah. Now instead of food being salad and yogurt, we can do food 2. Food equals salad. So here, somewhere, Amy here somewhere along the line here, Amy, female Amy salad is going to somewhere, this new entry will exist if you hated yourself enough to actually finish this whole table. Somewhere there would be this row. And now we can check that the names match and that the foods match. And that would work. Very good. Okay.
Professor?
Yes. Mm-hmm.
Why wouldn't you do name equals name 2 equals name 3? Because in order to have both yogurt, the 3 names would have to match.
Sure. Okay. Yeah.
Right. Like, am I thinking? Okay.
No, yeah, you're correct. You're correct. That should be the way to do it. Each time you cross multiply, this is the key that you're matching, and yeah, here the names should match. So yes, you're correct. Okay. So that's it for this class. I want to say one last thing. There's another way you can do this query, and I'd like you to try to figure it out. Okay, so there's another way. I'll give you sort of a hint where you'll have 2 queries that you're combining together into one query. Each of the 2 queries will look something like this. Will look like the first thing we tried to do. It will look more like that. But you'll have 2 of them, and then you'll be combining them together with another operation. That is to say, you don't need to do 3 cross multiplications. Okay, there's a way where you can have 2 queries that each have 2 cross multiplications, and then you combine them with an operator that we haven't used yet, but it's of the 7. So that's your hint. Please try to work on that. See if you can figure it out. And that's it. So thanks, guys. Have a good weekend. I will see you next week.